We will learn about ice formation on cooling coil after 6 to 7 hours of running. Today we are going to cover feedbacks from the customers. We ask questions from the customers, prepare a dot matrix for symptoms, possible type of failures, then diagnosis the process of steps, and then how to repair those defects. We get a feedback from the customer that ice formation on cooling coil after 6 to 7 hours of running. We ask questions to the customers. We ask from when the customer is getting this issue is to understand whether the issue is coming from the time of installation. We ask from the customer when was the AC get installed is to understand the age of the machine and to identify whether the issue is related to the installation. We ask customer about what temperature does the customer normally set the air conditioner. This is to understand the use by the customer. We observe, is there anything which is obstructing the flow of air? This is to check any airflow blockage. Then we ask when was the last service done? This is to understand whether the issue may arises due to lack of servicing. We ask customer that was the installation or the reinstallation done for AC recently. This is to understand if the issue is related to the installation. We prepare a dot matrix for ice formation on cooling coil after 6 to 7 hours of running. The defects which we include in this dot matrix chart is wet or dry service not done, filter or coil is clogged or blocked. External factors like airflow blocking, defective indoor fan motor, room temperature sensor defective, coil temperature sensor defective, indoor PCB defective, less refrigerant pressure, defect due to pinching of the connecting pipe, partial checking of distributors and capillary, compressor mechanical defect, low pumping, wrong selection of set temperature or fan speed. The possibility of the failures are divided into, like in case of indoor fan motor problem, it is under electrical defect. Room sensors, coil sensor defect or indoor PCB, it's under electronic types of defect. The compressor related issues, partial choking on capillary, partial choking on distributor, pinching of the connecting pipes are a mechanical type of defect. Improper temperature setting is again the usage related defects, and the service related issues is come under environmental conditions. So the parameters to be checked, like in case of wet dry service not done, we have to check the IDU dust condition and primitive maintenance services done. If it is okay, then we have to move to the next step. In case of external factors, like we have to check the airflow is blocked by any items or any other means. If it is okay, then we have to move to the next step. We have to educate to the customers. In case of defective indoor fan motor, we have to check the blower motor speed. In case there is a problem with the blower motor, we have to replace the blower motor. In case of defective room or coil temperature sensor, we have to check the room and coil sensor. In case it is defective, we have to replace the sensor. In case of defective indoor PCB, we have to replace the defective indoor PCB. In case of less refrigerant pressure or refrigerant leakage, we have to check the back pressure, check for the leakage. In case it is okay, then we have to move to the next step. If there is a problem, then we have to correct the leakage and maintain the correct range of operating pressure. In case of pinching of connecting pipes, we have to check the pinching, ensure that we have to correct the pinching pipe, then check the partial choking of distributors and capillary, check for any partial choking in the system. In case it is okay, we have to move to the next step, or we have to again do the seal system repair. Check for the compressor defect, check for the compressor's low pumping. If it is there, we have to replace the compressor. We check the incorrect set temperature or fan speed setting by the customer. If it is not okay, we have to educate the customer. Electrical socket testing procedure. We have to keep the clamp meter on AC voltage and check the voltage between phase, neutral and earth terminal. Voltage between neutral and phase is 230 volts. Voltage between phase and earth is 230 volts. And the voltage between neutral and earth is 0 to 2 volts. Symptoms of the product failure, like ice formation on the cooling coil. The defect is wet or dry service not done, filter or coil block. With required tools and equipment, a service jacket, a cleaning brush, digital temperature meter, jet pump connecting housing and accessories. In case of wet and dry service issues, we have to check the filters of the indoor unit. Is it clogged? Check the evaporator or cooling coil and blowers. Is it dirty? We have to clean the air filters in a dry service. We recheck the parameters like grill and return air temperature. This can be understood with the small YouTube videos. Linked is mentioned below. We have to do the wet service with the help of jacket and pressure pump. We have to recheck the parameters like grill and return air temperature. The method of doing the wet service is been available on a YouTube link given below. Then we have to recheck the parameters, observe the system's parameters like ampere, temperature, pressure after testing and commissioning the machine. We have to check the pressure. Operating pressure will be as per the below chart. Before starting the machine, we always check the supply voltage. We will recheck the parameters like temperature. Difference in inlet and outlet temperature should be 10 to 12 degrees centigrade after 15 to 20 minutes of running. The grill temperature will be 10 to 12 degrees centigrade after 20 to 30 minutes of running. We have to check the ampere checking. Ampere should reading mention the machine. Now another defect is of airflow blocking. We have to check if the airflow is blocked by any means like any object placed in the front of the grill, or if the AC is installed in such a place where the air circulations cannot take place as required. We have to check that airflow is blocked by the false ceiling. AC is installed within the cavity or blocking the airflow. AC is installed too close to the ceiling, minimum gapping of 6 inches is not maintained. In that case, we have to remove the objects which is creating the airflow block and educate the customer regarding the airflow blockage. Reinstall the AC in case the blockage is permanent or cannot be removed. Defective indoor fan motor is related to the running speed of the indoor fan motor. Visually inspection. Check the speed of the blower motor. Is it running slowly as compared to the normal speed? Measuring the blower speed with the help of electronic tachometer. We have to check the speed of the blower motor with the help of the electronic tachometer. Is it running slowly as compared to the normal speed? Required tools and equipment is electronic tachometer, clamp meter, measure the motor speed with the help of electronic tachometer, start the AC and let the blower motor run at the highest speed setting, fix one reflective tape on the blower, point the laser of the electronic tachometer to the blower motor. The tachometer display will show the speed of the blower motor. The RPM of the blower motor is normally 1300 with plus minus 10% variation. If bush of the blower is misaligned or dry, motor will not able to freely move. The blower need to align or replace the bush. Also, check the connecting nut of the blower and the blower motor. If it is not fully tightened, though the blower motors move freely, blower will move slowly. Defective indoor fan motor. If the indoor fan motor is running slow, replace the defective motor with a new one. While replacing the indoor fan motor, please check for the motor type AC or DC. Make sure that the correct motor has been used for replacement. In case of defect in the room or coil temperature sensor, check the room and coil temperature sensor for proper working. The required tools and equipment is resistance test for room and coil temperature sensor defect. Resistance should change as per the temperature. The above reading is at 34 and 19 degree Celsius. If the room or coil temperature sensor is found defective, we have to replace it with the new. In case of indoor PCB defect, 5-volt DC supply not giving to the sensor, we have to check if the indoor PCB is giving 5-volt DC supply to the sensor. The required tools for checking it is supply voltage test for room sensor and coil sensor for PCB. As you see, uh, indoor PCB should give 5-volt DC supply to the sensor terminal. If 5-volt DC is available from PCB to sensor, PCB is working fine. In case of defective indoor PCB, if the PCB is not giving 5-volt DC supply to sensors, PCB is defective. Replace the same with the new PCB. The factors of less refrigerant pressure. We have to check the refrigerant pressure. We have to check for the standing and suction pressure both. As per the chart given and the refrigerant we have used, we have to check the suction pressure, standing pressure. In case of R410A and R32 gases, we have to use the charging hose which are made for handling high pressure. The required tools and equipment is manifold gauge, digital clamp meter, digital temperature meter, electronic leak detector, refrigerants, vacuum pump, two-stage at least of 5 CFM, micrometer, charging hose, weighing balance, single gauge, nitrogen cylinder with regulator, soap and sponge for leak testing. Now how we can check the refrigerant pressure? We have to connect the suction valve, that is the low pressure side, to the pressure gauge. Keep the valve of the gauge closed. The gauge will show the pressure of the refrigerant. In running condition, it will be back suction pressure, and in off condition, it will give the standing. The refrigerant pressure is less than the values mentioned in the table. We have to check for any leakage, repair the leakage and maintain the refrigerant pressure. We have to inspect for oil traces, inspect the flare joints at indoor and outdoor unit for oil traces. Then we have to check for the bends, check the U bends in the indoor and outdoor unit for leakage. We have to carry out a leakage test. We have to release the balanced refrigerant from the system. We have to charge oxygen-free dry nitrogen in the seal system. Then we charge the nitrogen. We connect the blue color hose of the manifold gauge to the suction valve, that is to the low pressure side of the outdoor unit. Connect the yellow color hose of the manifold gauge to the valve of the nitrogen cylinder. Then we open the nitrogen cylinder valve slowly, then open the valve A of the manifold gauge as shown in the picture. We keep the valve B of the manifold gauge closed. Allow the nitrogen to flow to the seal system. Check the pressure and close the valve A when the pressure is 100 psi and check for major leakage. If 100 psi remains constant for 30 minutes, open the valve A again and increase the nitrogen pressure up to 150 psi and close the valve A again. We check for any leakage. If no leakage found, we increase the nitrogen pressure in the same process in the phase manner till 300 psi. That is 200, 250 and then 300 psi. In the absence of nitrogen, uh, it is observed that the refrigerant is used for leak testing. Though leak testing with refrigerant is not recommended, if someone is still doing it, process for applying pressure will be the same as in case of nitrogen. This apply a pressure of 100 psi initially and check for the leakage. Then increase the pressure level up to 300 psi in phase manner, that is from 100 to 150, then 200, 250 and finally to 300 psi. Check for the leakage in each phase. Then there are two methods of finding the leakage. One is by using soap bubbles method, and another is by using electronic leak detector. In case if leakage is not found, separate the indoor unit, outdoor unit and connecting pipes and carry out the leak testing individually. Once the leakage is found, release the nitrogen from the system and rectify the leakage. Recheck the repair joints for leakage. After brazing the leakage spots, refill the seal system with nitrogen up to 300 psi and check for the leakage. In case of condenser and evaporator, use of water tank is recommended for checking the leakage by dipping the coil into it. And hold the nitrogen pressure up to 300 psi for at least for 2 hours. If there is a drop in the pressure, check for the leak again, following the same procedure. Once the leak is free and it is confirmed, we release the nitrogen. Using a two-stage 5 CFM vacuum pump, evacuate the systems at least for 1 hour. Instead of checking for 1 hour, it is always recommended to use a micron gauge and a vacuum the systems up to 1000 microns. Two-stage 5 CFM vacuum pumps is recommended. Micron. Connect the blue color hose of the manifold gauge to the suction valve, that is to the lower pressure side of the outdoor unit. Connect the yellow color hose of the manifold gauge to the valve of the refrigerant and can place it on the weighing meter. Connect the red color hose of the manifold gauge to the micron gauge and vacuum pumps in series. Keep the valve on the refrigerant close. Open valve A and valve B of the manifold gauge. Start the vacuum pump and check the reading on the micrometer. Once the micrometer reading comes down to 1000, close valve A and valve B of the manifold gauge. Stop the vacuum pump. Sealed system evacuation is complete. Now press the Tere button on the weighing meter to set the meters to 0. Open the valve of the refrigerant slowly. Open the valve A of the manifold gauge slowly and keep the valve B closed. Refrigerant will automatically flow into the seal system. Check the weight of the refrigerant charge. Connect a new cane once the first cane is fully charged to the seal system. Close valve A and the valve on the refrigerant cane. Once the refrigerant required amount of refrigerant being charged to the seal system, after vacuum, charge refrigerant back into the seal system by measuring the weight of the refrigerant only. For standard installation, quantity of refrigerant required will be mentioned on the machine. Refrigerant required for additional pipe length beyond 3 meters is mentioned in the table below. Observe the system's parameters like ampere, temperature, pressures after testing and commissioning the machine. Operating pressure will be as per the below chart. Temperature set again. Difference in the inlet and outlet temperature should be 10 to 12 degrees after 15 to 20 minutes of running. The temperature will come 10 to 12 degrees centigrade after 20 to 30 minutes of running. We check the ampere. Ampere reading should be as mentioned in the machine figure. In case of pinching of the connecting pipe defect, we have to check the pinching connector. We replace the entire connecting pipe if possible or cut the pinching areas and brace a new pipe in the area. After bracing, check for any leakage. When leak free is confirmed, vacuum the system and charge the refrigerant back to the system. For leak test and refrigerant charging, follow the slide number 32 to slide number 48. In case of partial choking of distributors and capillary defect, it leads to the ice formation in the cooling coil. Tools which is required is manifold gauge and nitrogen cylinder. We have to allow nitrogen to flow from the suction line and block the discharge line to create a pressure of nitrogen. Allow the applied nitrogen pressure to flow through the discharge line to clear the blockage which is creating the choking. After flushing the nitrogen, charge the refrigerant back into the seal system by following the steps from slide number 45 to 48 and check the system's parameters after sealed system charging. If the choking is not clear after flushing, replace the evaporator. In case of compressor mechanical defect of low pump, we have to check the ampere reading during compressor running condition. It should be in the range of nominal amperes mentioned in the compressor's figure in good condition. In low pumping case, it should be low values than the above range. Check the suction pressure. In case of low pumping issue, it will be above normal suction pressure. If the compressor is found to have a low pumping issue, replace the compressor with a new one. Ensure that you have replaced the compressor with the same model compressors. In case of incorrect set temperature and fan speed settings, we have to ask the customers to start the AC as he normally starts. Then we observe the set temperature and fan speed setting that the customer is using. We have to ask the customer to select the cool mode. Ask the customer to set the desired temperature. Temperature range of 24 degrees centigrade to 26 degrees centigrade is recommended as it is the most comfortable temperature for human being. Or ask the customer to select the auto mode. Temperature will be automatically get selected as 24 degrees centigrade to 26 degrees centigrade. Check the set fan speed. If it is set as low, ask the customer to set as medium or high. Fan speed setting in different models of remotes shown. Thank you.